set?
Yeah.
Alright, let's go.
So, you need to work on the citric acid cycle, right? Like, to tell you the truth, I totally did not get it. But hey, I've got this awesome song to teach it to you. Just like ignore the Japanese though, okay. Clean energy, use the 8-step citric acid cycle. It'll produce CO2 and NADH to make ATP.
Must be kidding.
Begins when enzymes take H plus from acetyl-CoA, which binds to acetyl acetate, makes us citrate. Isomerization moves its hydroxyl from the... What?
Alright.
Carbon to another.
This is gonna be different, okay?
What?
No. Alright. So to start this whole damn thing, you gotta do the whole hydrolysis bit, okay, honey? Then with this whole isomerization reaction, where there's water removed and put back. What the fuck? Huh? Why can't it just stay instead of leaving? But no. This hydroxyl group has to go to a neighbor. That's why water leaves in the first place. Just leaves. Then there's these freaking 4 oxidation steps, okay? Freaking carbon decides to change its name to a carboxyl group. But then it's unstable, and it releases CO2! To make things worse, honey, this long-named complex does oxidation for NADH, CO2, and this high-energy thioester bond. Great, high energy, not cool. Phosphate comes along and BAM! Displaces COA to make another phosphate bond. What's the purpose of that? And what the hell is phosphate good for, huh? It gets used by GTP to make GTP. But, you know, bacteria and plants, they gotta be different. In bacteria and plants, they use the phosphate to make ATP instead. Nice. Really, make things more complicated. This thing called FAD takes 2 hydrogen atoms from the succinate, whatever it is, which in turn creates water and furanate. The names sound alike. I mean, come on, can't you have some distance? Succinate, furanate, what? The hydroxyl group then gets moved to a carboxyl atom. Just FYI. So it's moving itself. This carbon group with a hydroxyl gets converted to a carbonyl group. Again, with the words sounding the same. But you lose the rest of my mind, why don't you? Finally, at the end of all this fun stuff, the oxaloacetate is remade so that, guess what? The whole bloody thing can continue from step 1, over and over again. Oh God help me, I'm done.